Hello, in this video I'm going to show you how the QUDI is working in our lab. QUDI as an open source platform consists of three main parts that are needed to be defined in the config file. The hardware part will contain the classes that are defined for each instrument with the IP address and the specification that are required, so we define it here in the config file. And then it is the logic, which is the class of logic of measurements. All the class, including the locations that are defined inside the project, are being to defined here. Finally, there is this GUI. The GUI, which is a class of graphic, it is based on mostly PyQt5, which is defined in the config file. If we go, for example, to the confocal GUI complex, we can see that all the related methods and connections are defined. The activate and deactivate module needs to be defined with this software architecture. Now let us run the software. So we now run the NI card acquisition to observe the voltage change. As you can see, the laser power, when it is changed, the voltage is also changed on the photodetector when you see on the screen. In the next module, we have this confocal. The confocal will move the piezo stage by giving an analog output, and then it shows you the result of the voltage on the photodetector. Then you can see here that the interaction between module is well controlled by thread lock. So this thread lock will avoid accessing one method by multiple threads, and you can see that you cannot run one with the others. So when I move the target, the voltage on the photodetector is changed. So it shows that the modules can work together, but the threads, when there is a resource that is used by a thread, it cannot be used by another thread, which in this path. So it has been care. And now let's go to the ODMR. In the ODMR, the microwave frequency will be swept. And now let's put like -7 dB for the power of the microwave frequency, and the PL that we showed last is plotted. So you see, in some frequency the PL is reduced, so it means that you have this resonance, and we can fit it, and then we can like save it. Let's save like ODMR fitted to be saved in the computer. And the last module is like pulse measurement. In the pulse measurement, we'll do complicated pulse experiment. In this case, let's do a T1. For example, for resolution of 1 microsecond, I just put counter beam width as 1 microsecond, and set the T1 modules. And now you can see that. Let's put it on the laser on the modulation. You can see now the raw data of the laser, laser that has been plotted. Uh, so if I improve the extraction method, so this is the signal processing part. So in the extraction part, if I put the like use the extraction method of convolutional derivative, it will take the convolution, and it will do with the standard deviation of 5. It will then it will take the derivative. Then you will see that there is this exponential decay, and this exponential decay is basically the T1. So here is like really one of the main contribution of me here. So this part is working with now with a couple of time tagging devices. It can now work with national instrument card, which is quite complicated if you want to do like some binning and like for photon counting, or even if you should like to like getting analog parts. So there is really a lot of works and contribution. So on the last part is also here is also, I mean, this is fully our contribution. Basically, in this complex pulse measurement, you can really move to position. And for example, we are in this position, we have the signal. You see, this is a signal on the photodetector. Uh, in each channel, you want, you can see this thing, and you can do really whatever you want. You can measure like contrast, like which is like the apply microwave, and then it sees what will be the result of this basically resonance dash the height of the resonance. It will find the height of the resonance, so it will find for each pixel. So now let's do like 100 micrometer by 100 micrometer for 5 point. You see, In the second plot is plots the contrast, and the first one is the PL. So it shows that in the center you have higher contrast of the signal. Probably you have more microwave power and this kind of thing. And you can simply right click and save it. You can do really whatever you want with this platform. You can really do T1, any all of the module that you see, you can do it. I hope that it was useful. Thanks for watching.